All right. So for this video lesson, this is the second day of dividing radicals. So just a few reminders when we're dividing radicals. So one, it's best that we check that if the radicands can divide evenly, then we can just divide, right? So if it's like root 10 divided by root 2, 10 divided by 2 is 5. So then we just get root 5 there. Okay. However, sometimes the radicands will not divide evenly. And when this is the case, we need to either rationalize the denominator or simplify the radicands. Okay. And then after we do that, then we need to divide the radicals. And just a reminder to always put your answer in fully reduced or simplified terms. Okay. So steps for dividing radicals. One, we'll check if the radicands divide evenly. If it does not, 2 and 3 are kind of interchangeable. You can simplify the radicands first and then check again. And then if they do not divide evenly again, you can rationalize the denominator. You can rationalize the denominator before you simplify the radicands, but this will give you usually a really large number in front of the radicand. So it's usually easier for us to simplify it first and then check if the simplified radicands will divide evenly. Okay, so let's get into some more dividing. Okay, so first we need to check if our radicands will divide evenly. So 126 divided by 112 will not give us a whole number. So let's go ahead and simplify this right away, right? You could rationalize the denominator by multiplying the numerator and then denominator by root 112. But again, we'll get a really big number, so it's probably best to just simplify first. Okay, so let's start with 126. That will be broken down into 2 and 63. 63 can be broken down to 9 and 7. 9 is broken down to 3 and 3. Okay, so that is root 126. Now let's do the same for root 112. We get 2 and 56. We get 2 and 28, 2 and 14, and then 2 and 7. Okay, so let's go ahead and put these in. So 8 root 126 becomes 2 times 3 times 3 times 7. And again, we're looking for pairs here. And root 112 will become 2 times 2 times 2 times 2 times 7. Okay, so we'll look for pairs because we're taking the square root. So there's 1, there's 2 in the denominator, and then I see we have 1 in the numerator as well. So 8 times 3 is 24, and 2 times 7 gives us root 14. In the denominator, we're taking out 2 sets of 2s, so that gives us 4 root 7. Okay, now that we have reduced our radicands, we need to check if the radicands will now divide evenly, right? 14 divided by 7, they will. Okay, so that is excellent. So 14, so then we can expand this to 24 divided by 4 times root 14 divided by 7. And that will give us 24 divided by 4 is 6, root 2 for our final answer. Okay, so for this next example here, and again, I encourage you to pause the video and attempt this on your own. Okay, I'm going to go ahead and solve this. So first, let's check if our radicands will divide evenly. 24 divided by 2, sorry. That will give us a value of 12. So that's nice. So we can rewrite this as 10 divided by 20 multiplied by root 24 divided by 2. Okay, so 10 divided by 20 is 1 over 2, and 24 divided by 2 is 12. So this gives us root 12 divided by 2, right? Root 12 multiplied by 1/2 will be root 12 divided by 2. Okay, we need to simplify our root 12. So 12 can be broken down to 2 and 6 and 2 and 3. I have a pair of 2's, which I will take out. So that gives us 2 root 3 divided by 2. In this case, because the 2 is the coefficient to the root 3, those will cancel, and that will give us a final answer of root 3. Okay, and again, just make sure we always put our answer in fully reduced terms. Okay, so root 2 divided by root 3. If we do this, we will get not a whole number. So we need to first rationalize the denominator. It's already in lowest terms, right? So we'll multiply the numerator and the denominator by root 2. Root 3 times root 2 gives us root 6. And root 2 times root 2 gives us root 4. Root 6 is simplified, and root 4 is 2. So it gives an answer of root 6 divided by 2. All right, we are motoring. Okay, and we're just going to continue. So again, I will encourage you to pause the video and try these on your own. Okay, so for root 5 divided by root 7, that will not give us a whole number. So let's rationalize this fraction, multiply the numerator and the denominator by root 7. Okay, when you're multiplying a mixed number and a radical, you just multiply the numbers in front and then multiply the radicands. So 4 times 1 is 4, and then root 5 times root 7 is root 35. Root 7 times root 7 is root 49, which is a perfect square, so we can simplify that. 35 is already in lowest terms, so we will leave that alone. So we get 4 root 35, and the square root of 49 is 7. All right. Next one, number 5. Root 6 plus root 2 divided by root 3. That we can rewrite this as root 6 divided by root 3 plus root 2 divided by root 3. Okay. Root 6 divided by root 3, that will give us a whole number. So we can go ahead and convert that. So root 6 divided by 3 is root 2, right? Over here, root 2 divided by root 3, that will not give us a whole number. So we need to rationalize that. So we will multiply the numerator and the denominator by root 3. And that gives us root 6 divided by root 9, which is equal to root 6 divided by 3. Okay, so plus root 6 divided by 3. So the square root of 6 divided by 3 is root 2 plus the square root of 6 over 3. Okay. And this is our fully simplified answer. We can rewrite this so it's a little bit more proper, right? So in this case here, we are over 1. So if I multiply the fraction on the left by 3 to make it an equivalent fraction, so we will have the same denominator. So that will give us 3 times root 2 is 3 root 2 divided by 3. And we're going to leave root 6 divided by 3 alone. Now that we have the same denominator, we can combine the numerators. So we get 3 root 2 plus root 6 divided by 3 as our final answer. All right, so we are continuing. We're dividing the following radicals. Okay, note this one does not have a radical in the numerator. It just has a radical in the denominator. So let's go ahead and rationalize this radical. Okay, so we'll multiply it by just the radical itself. We're going to leave that whole number alone. So multiply by root 5 divided by root 5. And this will give us negative 1 root 5 divided by 4 root 5 times 5 is 25. Okay, hopefully you are saying root 25 will give us the whole number, or 25 is a perfect square. You're absolutely right. I'm also going to rewrite this. Negative 1 root 5 is the same thing as writing negative root 5 divided by 4 times 5. Negative root 5 divided by 20 is our final answer. Okay, so we will continue. And again, as we just do, similar questions, I would encourage you to pause the video and try this on your own, right? Okay, so we have root 72 divided by root 8. Let's check if 72 divided by 8 will give us a whole number. It indeed does. 72 divided by 8 is 9. Okay, so we can rewrite this. There's a 1 in front of that root 72. So it can be 1 over 2 multiplied by 72 divided by 8. So it is 1 over 2 multiplied by the square root of 9, which is 1 over 2 multiplied by 3. And half of 3 is 1.5, or 3 over 2 if you're in fractions. All right, so again, it's important to first observe if our radicands will divide evenly. It's just going to save us some time. We don't necessarily need to simplify root 72 or root 8 if those divide evenly into one another. Okay, so next one, negative 2 root 98 divided by root 8. So I'm checking if 98 divided by 8 will give us a whole number. It does not. Okay, so let's simplify these radicands first. Okay, so 98 will be broken down to 2 and 49, and 49 will be broken down into 7 times 7. Okay, root 8 is just 2 times 2, or sorry, 2 times 4. And then 4 is 2 times 2. So to get to 8, it's 2 times 2 times 2. Okay, so let's rewrite this. So negative 2, and then root 98 becomes 2 times 7 times 7. And root 8 becomes 2 times 2 times 2. Okay, again, we are looking for pairs here. Right, that is not one. Our 7s are a pair. And we have a pair in the denominator, our 2s, right? So let's go ahead and take out the 7 and the 2. So negative 2 times 7 is negative 14. Sorry, sometimes my hand will make a big line. Okay. So 2 7s come out, multiplied by negative 2 gives me negative 14 root 2, divided by the 2 2's that I'm taking out is 2 times root 2. Okay. Hopefully at this point, you recognize that root 2 divided by root 2 will give us 1, and negative 14 divided by 2 will give us 7. So we can rewrite this as negative 14 divided by 2 times root 2 divided by 2, which is equal to negative 7 times the square root of 1, which is equal to negative 7 multiplied by 1, which will just give us an answer of negative 7. All right. And the last one we are going to go through today, 4 root 15 divided by negative 1 root 2. So hopefully you recognize that 15 divided by 2 will not give us a whole number. So we need to rationalize the denominator here because 15 is pretty simplified already, and same with root 2. So let's go ahead and rationalize that denominator. Okay, so multiply by root 2, and that will give us 4 root 30 divided by negative root 4. Okay, hopefully you're recognizing that root 4 is 2. So we can simplify that right away. 4 root 30 divided by negative 2. Don't let me forget the 30. Okay, now we need to reduce root 30. So 30 goes down to 2 and 15 and 3 and 5. We have no doubles there. We are taking the square root. So root 30 is as simplified as we can get. Okay, now let's look at the coefficient in front of root 30. So we have 4 root 30 divided by negative 2. So 4 divided by negative 2 gives us negative 2 root 30. All right. I would like you guys, I know we completed this in yesterday's video lesson, but if you did not do that already, please take the opportunity to solve that today. The answer for this problem, the width is equal to 5 root 2 over 3. Okay, so if you did not solve that yesterday, please take the time today to attempt this problem to find the width. And there is the answer right there. Okay, so in summary from today's learning, remember there are 2 types of radical division. So one is when the radicands will divide evenly. And if this is the case, we will just go ahead and divide the radicands. So if we had like root 9 divided by root 3 is equal to root 9 divided by 3, which is equal to root 3. Okay, that's easy. If they do not divide evenly though, we need to either simplify the radicands first or rationalize the denominator, okay? If you simplify the radicands first, you're going to be working with smaller numbers, so it's probably going to make your life a little bit easier. Okay, always remember to put your answer in fully reduced or simplified terms. Okay, and here are the steps for dividing radicals, which we talked about today. Okay, your assignment are the same questions from yesterday. So make sure that you take the time today to complete those. And if you need help with anything or you have any questions, please do not hesitate to ask. And I hope you have a lovely day.